Hey guys, it's Mrs. Katz again, and this is the video for the backside of the Unit 2 mid-unit test review. So we're going to get started right now. Number 16 asks us to complete the ratio table, and basically what we're looking for is what is the known relationship. We know that for every 13 on top, there's 1 on the bottom, and then we're going to use that information to apply it to the ratio table so that we can find the missing pieces. So let me show you what I mean by that. I know that to get from 1 to 2, I had to multiply by 2. And remember, in every case here, we're either multiplying or dividing to get from one unit to the next. Let me blow this up just a little bit so you can see my little small 2's in there. Okay, so we're going to multiply by 2. And because these are ratios and we want to keep them equivalent, we know that whatever we do on the bottom, we need to do on the top. So we take 13 and we multiply that by 2 and we get 26. Let's apply that same logic again. To get from 13 to 39, I multiplied by 3, and whatever I do to the top, I have to do to the bottom to keep them equal. So we know that this will be 3. And then we go over here, and we know 13 times something probably equals 52. So let's make a guess. I know that 3 times got me 39. So my guess is that 13 times 4 will probably get me the 52 I'm looking for. So I'm actually going to do the math, and it checks out. So I know that it was 13 times 4 that got me to 52. Whatever I do to the top, I'm going to do to the bottom, and we know this is a 4. Now remember, I told you in class, we're not skip counting, even though this is 13 times 1, times 2, times 3, times 4. That's just a coincidence of this particular set. Don't ever make the assumption that we are skip counting or that the order will remain the same. You always want to go back to the known relationship and apply it to the pieces that we don't know to find them. So let's take a look at the second question here. To get from 7 to 21, I multiplied by 3. Whatever I do on the bottom, I also have to do on the top. And if I do that, I know that this number is going to be 12. Now notice, this is 4 times 1, but this is 4 times 3. So this is a perfect example of how they didn't necessarily skip count in order. We need to use what we know to find what we're missing. So we're going to go over here to 4 and 20. To get from 4 to 20, I multiplied times 5. Whatever I do on the top, I do on the bottom. So I know that this number is going to be 35. And the last one in this set, to get from 7 to 56, I knew I had to multiply by 8. Whatever I do on the bottom, I do on the top. So we know this is 32. Again, all of these fractions can be reduced down or simplified to 4/7. But they don't skip count in order, so you can't use that as your guide. Each time you go back to the something that we know, you can use any of them, and apply it to find the piece that you don't know. And if you want to check your work when you're finished, if you were to simplify all of these relationships here, every last one of them should simplify down to 4/7 if you did it correctly. All right, in question 18, let's take a look at what we know. A couple things that we know here. First of all, this is the known relationship, and it's not in a simplified form. But because these numbers are compatible, we don't have to simplify it. We can use them just as it is. Now, we can choose to simplify should we want to. And if we did that, when we divide by 9, you're going to get 2 here and 3 here. So we could use that new fraction, that new ratio, 2/3, to figure out everything else. But I'm actually going to use division in this case. So I'm going to take 27, and I'm going to go to 9. To get to 9 from 27, I had to divide by 3 this time. Remember where we start and where we finish. I'm starting at 27. I'm going to divide by 3 to get to 9. Whatever I do on bottom, I do to the top, and 18 divided by 3 happens to be 6. Now I can work this relationship. How did I get from 18 to 2? Well, 18 divided by 9, equals 2. Whatever I do on top, I'm going to do on the bottom, and 27 divided by 9 is 3. And you'll notice this 2/3 is the same thing we have here, because every one of these fractions, these ratios, should simplify to 2/3. All right, and then the final one in this set, let's go from here to here because these are really easy compatible. So from 9 to 90, I'm going to multiply by 10. Whatever I do on the bottom, I do on the top, and 6 times 10 is 60. And that is how you solve a ratio table. All right, in question number 19, it asks if the pairs of ratios are equivalent. There's two ways for us to test this theory. First, can we simplify to make them equal? Well, 4 and 6 share a factor of 2. When I divide by 2, I get 2/3. Since they are the same, the answer is yes. There's one other way we could test this out. We could take 2/3 equal to 4/6. And what we know about ratios is that if we cross multiply, so we multiply the numerator of one with the denominator of the other, it should be equal the cross multiplying on the other set. So numerator, denominator of two different fractions, numerator, denominator. If you notice, 2 times 6 is 12, 3 times 4 is 12. Since they are equal, we know that these two ratios are equivalent. Either method will work. All right, let's take a look at question number 20. In question number 20, it asks us if these two ratios are equivalent. And again, let's try to simplify. Is there a common factor between 14 and 20? Yeah, there's a 2. So I'm going to divide by 2, and I'm going to find that this is 7/10, and that is 7/10. So yes, these are equivalent. And again, if I were to use the other method, 14 times 10 is 140, and 20 times 7 is 140. Since they are equal, our ratios are equal or equivalent. All right, number 21, okay? Number 21 asks if these ratios are equivalent. Let's simplify them all down to their lowest forms. So 12/40, I know 4 goes into both. Let's see what that gives me. 3/10. And here, does 3/10 equal 6/10? No. So no, these are not equivalent. And we can simplify 6/10 down, but we really don't need to because we have them now with a common denominator. And I know I have more pieces in this one than I do in this one. But if we were to simplify by a factor of 2, you'd find that we got 3/5. And 3/5 and 3/10 are not equivalent. If we were to cross multiply, you'd get 120 over here, and you get 240 over here. And since they are not equal, the answer is still no. All right, I'm going to make this a little bit bigger so you can see the whole problem. Zoom out a little bit. All right, Jada sent 72 texts in 6 days. At this rate, we want to know how many texts she will send in 10 days. Now, in this case, let's set this up, okay? Looking at the relationships here. We know we have 72 texts in 6 days, okay? They gave us the days, and we need to find the texts. Now, think of this as a ratio table and set it up this way. These are your texts. These are your days. They gave us 72. That's the known relationship. Now, looking at this problem, the 6 and the 10 are not terribly compatible. I don't know how to get from 6 to 10 using a whole number. But these guys have a common factor here. It's actually 6. So I'm going to divide by 6, and I'm going to rewrite that fraction over here just so you can see it. But if I divide by 6, this becomes 12, and this becomes 1. Now I can use this relationship to work backwards. How did I get from 1 to 10? Times 10. Whatever I do on the bottom, I have to do on the top. So this will be 120. 120 texts in 10 days. Now, if you didn't want to use ratios, let's think about it. We can figure out how many texts she does in a day by dividing, right? 6 goes into 72 12 times. So if we wanted to know, let me just show you this. I'm going to actually move the paper away for a second. If we know that she sends 72 texts in 6 days, and I want to know how many in 1 day, just so I can kind of get a rate here, we can divide by 6. We can divide by 6. When we do that, we get 12. So it's 12 texts per day. Once we know the daily rate, we can then go and figure out how many days. So it asked us, How many will she send in 10 days? Well, 12 per day times the 10 days that she sends her texts equals 120 texts, just like we got using the ratio table method. Okay. Question number 23. Coke costs $3.90 for 6 cans, and Pepsi costs $2.80 for 4 cans. We want to know what the better deal is. Okay? Well, the better deal is the one that we're going to pay the least amount for, and we need a unit rate for that. So to get a unit rate here, we're going to take the $3.90 and divide it by the 6 cans that we have to find out how much we're paying for each can. Don't forget these are decimals, so you have to bring your decimal up. 6 goes into 39 6 times. That gets me 36. Leaving me with 3, bring down the 0, and 6 goes into 30 5 times. So we know that Coke is 65 cents per can. Let's check Pepsi. We start with the $2.80 we spent, divide it by the 4 cans that we have. Don't forget to put your decimal up. And 4 goes into 28 7 times. Don't forget to bring that 0 down. 4 goes into 0 0 times. So Pepsi is 70 cents per can. So which one is the better deal? Coke. And in Atlanta, you would hope that that was the case. Okay, Coke is the cheaper per can cost. All right, in 24, Dunkin' Donuts sells a dozen donuts for $12.44, and Krispy Kreme sells half a dozen donuts for $5.94. We want to know which one's the better deal. Again, same kind of thing. A dozen is equivalent to 12. Okay, so we're going to take that $13.44 and divide it by 12. Now, because I've got no room really to work here, I'm going to go off to the side here and do that problem so we can get a little bit more space. Divided by 12. 12 goes into 13 once, leaving me with 1, and then bring down the 4. It goes into 14 once. Oops, 12. Leaving me with 2, bring down the 4. And it goes into 24 twice. Don't forget that that decimal floats up to the top. So Dunkin' Donuts costs $1.12 per donut. It's a lot of money when you're just eating a donut in 5 seconds. Now, half a dozen is half of 12, which is 6. So let's find out how much Krispy Kreme charges per donut. Don't forget to bring your decimal up. 6 goes into 59. 9 times, that's 54. And when we subtract, we get that, and we bring down the 4, and it goes in 9 times. So Krispy Kreme, KC, equals 99 cents per donut. So who has the better deal? Krispy Kreme. Because their donuts are cheaper per donut. Explain how to simplify a ratio is in question number 25. And you should write something to the effect of find a common factor of top and bottom number and divide by that factor. By that factor. You know you're done when the only common factor is 1. All right, so let's simplify these ratios knowing that that's the case. We're going to start with 9 to 27, and I'm going to rewrite it in the fraction format. 9 and 27 share a common factor of 9, so we're going to get 1 to 3. 4 and 26 share a common factor of 2. When I divide, I get 2/13. 14 and 56, I don't know what goes in there. I may not be able to get the highest one, not sure yet, but I do know 7 goes in. and that gets me 2/8. Now that I've got 2/8, I realize that 2 and 8 still share a factor because 2 goes into both. So we'll divide one more time to get 1/4, and that is our simplified ratio. And in the case of number 229, apparently, which should have been 29, we just get 11/13. There is no common factor between 11 and 13 except for 1. So we start off finished. All right, I hope you all study really hard and get prepared for your test, and let me know if you have any questions.